Hello, this is Lisa Frisbee of the M2MZone, and it is my pleasure to welcome you all to the M2MZone webinar on smart grids titled Strategies to Transport Critical Utility Distributions Applications. This webinar is sponsored by Aeris and GE. Before we start, there are a few items that I would like to bring to the attention of our viewers. Today's presentation will be approximately 45 minutes long, followed by a 15-minute Q&A session with our panelists. This is an interactive webinar, so we're eager to receive your questions at any time. Just type them into the Q&A window on your screen. Our speakers will address as many of the questions as possible during the Q&A segment following the presentations. Please address your questions to all panelists, which is the default setting in the Q&A box. This presentation will be archived and available for viewing later on in the events section of the M2MZone website. Also, if anyone would like to see more detail in the slides, simply click on the Enlarge button in the upper right-hand corner. At this point, it is my pleasure to introduce our moderator for today's session, Dana Verstegen.
Good morning, good afternoon, everyone. Really glad to have you here for this session. I think you're going to find it really valuable. So we've got about an hour, and during the next hour, you're going to hear from Edgar Samor. He's a Senior Product Manager at GE Digital Energy, and Aeris founder and CTO Z Hossein. They can answer any questions that you might have on the material, of course, as well as broader questions about the smart grid industry and M2M and IoT overall. After the session, we will be sending you a copy of the slides as well as a copy of the recording of the session. So before we hand this over to Edgar, I wanted to put up a poll question. So here it is. What is your greatest concern about connecting your grid? And we ask, you may have all of these, but we ask that you select the one of greatest concern. We want to make sure that we address these concerns in our remarks today. So if we could take a moment and each of you could provide an answer, we'll just pause. Okay, hopefully that was enough time for all of you to put in an answer, and we're going to tabulate those answers now and put them up on the screen. Okay, so it looks like far and above, data security is of great concern. And we're going to make sure that we address that in a couple of different ways. And then if you have specific questions that we don't address, please do put them in the Q&A box, and we'll be sure to address them at the end. So with that said, I want to now turn this over to Edgar with General Electric. Edgar?
Thank you, Dana, and good morning and good afternoon, everyone. We appreciate the opportunity to speak with you today about this topic. So we're going to try to address strategies to transport critical applications on the distribution grid reliably and with high availability. And the way we're going to address it today is we're going to offer some ideas from the GE side in terms of the hardware and the RF technologies. And then Z from Aeris is going to talk about what we can do or what can be done today on the cellular side as well. To start with, we're going to talk a little bit about the drivers that are driving a lot of utilities to automate the grid. Some of the major ones that we're seeing today in the industry as trends are the revenue optimization. The higher available the grid is, the more uptime you have, the more money you have coming in. So this is one of the major drivers we've seen. Other ones we've seen is the aging grid. A lot of folks have devices that have been in service for 30, 40, 50 years. So when the time comes to upgrade these primary equipments, whether they are transformers, switches, reclosers, and so forth, a lot of companies are actually investing money to automate these, to add controllers to them, and to also add communication networks to have these controllers communicate either between one another or between themselves and the control center. Other main drivers are also government and state initiatives, whereby certain states, as an example, California and others, are required by year 2020 or some other years to have a certain amount of energy generated by renewables. So this could be wind farms, solar, and so forth. And the challenge for the utilities is the more of these distributed generation you have online, the challenge becomes bigger to make sure the grid is reliable, and also the power quality on the grid is also maintained and managed correctly. And this is one of the major drivers for DA. Now we're going to talk a little bit about certain applications, and here I bucketed them in like very high-level umbrellas. So what we're seeing today mainly is the AMI applications. There's SCADA, and SCADA could be also monitoring as well. We're seeing a lot of protection applications also being deployed on the grid, on the distribution grid as well. So from a high level, if you look at the requirements for these major buckets, AMI can tolerate minutes of latency. So if you pull a meter, it can take sometimes 10, 15 minutes to reach the information to reach the data center, and that's fine. That's no problem at all. Security requirements have been low in the past, but we've seen at certain hacking conferences how certain meters were hacked. So over time, I think the requirements are becoming more stringent on these meters. Now for SCADA, a lot of SCADA applications, whether they are monitoring, diagnostics, or even remote control, they can tolerate around 2 seconds of network latency. And on the security side, they are high because, if the grid is compromised, somebody can log in and remote control a switch and turn off power on a hospital or some really critical assets. So this is very important. Monitoring can also tolerate latencies of 2 minutes and so forth. Protection applications, this could be either DG protection such as wind farms or solar farms and so forth, or they could be just, recloser protection applications using protocols like 61850. Typically, these are a bit more demanding on latency, especially when we're using 61850. And we've seen anywhere between 50 to 100 milliseconds between peer-to-peer controllers, one-way requirement for latencies. Now, for security, pretty much this is very critical as well because, again, somebody hacks on the network, they can log in and flip a recloser open and cut off power on some critical, section of the community. So we'll go now from the applications to see what wireless technologies are available today to address these needs. And, pretty much there's a lot of technologies have been deployed successfully by many vendors, many utilities. And you can make the case for each one of them separately, but let's just kind of take a look on them. So there's Wi-Fi or Wi-Fi mesh. It has very low latencies in the milliseconds and throughputs of hundreds of megabits per second if things are optimized within range and so forth. And the challenge with it is range. It cannot go for more than a mile if really optimized, so you have to have your repeaters pretty close by. 802.15.4 or 6-LoWPAN mix of technologies, they have higher latencies, usually in the hundreds of milliseconds, and throughput is somewhere in the between 250 kilobits per second. I've seen recently some as high as 600 kilobits per second. And they are highly available just because of the nature of the mesh network. If you lose one section, you go back to another one. And range usually within hundreds of meters. There's low power wide area networks. This is good for certain applications, but not others. This is a technology whereby you can put a battery in, let's say, a gas meter or a water meter that can last 10 years. And the data coming out of this meter is very, very minimal at very low rates. So this is why one of the main reasons the battery can last so long. So this is only good for certain applications just because of the bandwidth on it is very little. Usually it's in the bits per second, so hundreds of bits per second. But the range is pretty far just because of the sensitivity of the network and so forth. WiMAX, it's a 2020 catch 2020. Very low latencies, high throughput, high availability, and range can be high, but also the cost can be high because of the primary cost for the equipment and also the licensing as well. There's licensed narrowband technologies. These have throughputs in the hundreds of kilobits per second, usually less than 120 kilobits if you're using QAM64. And they are very highly available just because you purchase the license for the spectrum and then you own it. So not many people can interfere with it. And usually there's a lot of redundancy model as well with it. Real quick, also there's like cellular networks and MVNOs. The cellular carriers, we're all familiar with them. They have very high throughput. The challenge with them usually is the availability, even though they are very reliable networks, but typically they cannot give SLAs. So it's the best effort transmission of information. And there's also the M2M MVNOs like Aeris, kind of similar to cellular networks, but one of their benefits is the ability to interface with multiple carriers versus just one carrier. And this is what Gilles is going to talk about in a few minutes. So moving forward, how do we make decisions in terms of picking a solution? Apparently, like I mentioned, we can make the case for every single one of these technologies as a potential for transporting distribution automation reliably. But there's actually a lot of catches that we have to keep in mind when making a decision. Starting from the CapEx, how much you're going to invest in the underlying infrastructure, the operational costs, whether it's cellular monthly fees, whether it's maintenance fees, server fees, and so forth. There's operation and network management, cybersecurity. We also want to consider network availability, kind of compare all these technologies side by side and figure out which one provides the availability to meet the requirements for the network. There's latency as well, especially if we're doing protection on the network. These are very important. And bandwidth requirements, especially when we're converging multiple applications on the same network versus just doing a simple SCADA poll. There's the range as well, and this is very important once we start talking about rural areas where the density of communication infrastructure is less, and coverage as well. So if you look at as an example, we'll take a couple of them here, and then I think the slides can be available later for review. But just for the sake of time, we'll take a couple of them here. If we consider capital cost, Tier 1 carriers and MVNOs, cellular carriers, typically the cost is pretty minimal here, and you only have to buy the modem. And usually the antennas on them are simpler, just because there's ubiquity of cellular all over the place. So the capital cost on cellular is pretty minimal, whereas on the private narrowband or private unlicensed broadband, like we're going to present here, they can be much higher depending on the topology, just because you require an underlying infrastructure to support them. You need repeaters, towers, and so forth. So the cost is high. And the cost can be higher for private narrowband, especially because there's also licensing fees for the spectrum. Now, in terms of operations, typical Tier 1 cellular carriers, may charge 10, 15 to 20 to 30 bucks a month per device for certain megabytes or gigabytes for access. We've seen MVNOs such as Aeris having a bit more optimal prices, catered for M2M, going as low as $1 a month for very low usage. The operational costs for narrowband and unlicensed broadband are a little different. There's no monthly fees, but then there's the spectrum cost, there's the site maintenance, there's the employees that need to overhead to manage the site. So this all adds up at the end. We'll take another one here. Let's talk about cybersecurity. The cellular carriers are pretty secure these days. They use very strong standard protocols for encryption, authentication. So getting into them is pretty difficult. Similar standards are used in private narrowband and unlicensed broadband as well. But in my opinion, these have a bit more advantage just because they are proprietary. So breaking into the RF layer is a bit more difficult than breaking into standard-based RF layers. So this has just added more benefits here. In terms of network availability, Tier 1 carriers have been usually very reliable for a lot of applications, but what we've seen talking to a lot of utilities at GE here, a lot of them are or have been reluctant at using cellular carriers, especially for critical applications and for protection purposes, mainly because carriers have not been able or are not willing to give SLAs, meaning a promise for the network uptime or network speed and so forth. So the carriers in this case just offer a best effort service. And like I mentioned, usually it's very reliable, but if you have a critical infrastructure, you need some SLAs. Now, we've seen companies like Aeris, they come into play here, whereby they offer, because of their relationship with multiple carriers, they have failover scenarios whereby if one carrier is lost, they can failover automatically to another one as a backup, which I think is very critical for these kind of important applications. And this is where these kind of technologies shine versus just no SLAs. In terms of private and unlicensed broadband, they're pretty much highly available just because of the architecture. A lot of them use self-healing mesh, which can give pretty good availability on the network. And latency in usual, pretty much everyone can meet latency requirements for the applications. If we talk about 3G applications or 3G cellular networks, usually it's 400 or 500 millisecond latency for M2M, or sometimes can go down to 200 or 300. This is good for most applications, but once we start talking about protection, like 61850 Goose, these need something less than 100 milliseconds. So you would need to either go to a 4G LTE, which we've tested to be as low as 35 milliseconds one way. We've done that test on the Verizon network a while back. Or you can also use private unlicensed broadband as well for that one. Now, moving forward, how do we build these networks? There's the traditional way that actually has been changing recently, whereby you have an individual network for each application, and this happened over the last 20, 30 years. But with the advent of cellular infrastructure, cellular networks, and broadband, things have changed a little bit. So in this kind of scenario, you got application one, it could be SCADA. It has its own separate network. Application 2 could be protection, separate network. 3, teleprotection or voice over IP or video over IP. So these may have separate, maybe segregated into separate networks. But then there's the concept of converged communication on the single infrastructure of network, which brings a reduction in CapEx because you need less equipment in place, less installations. And also operation-wise, it's simpler just because you pretty much have a single network to manage everything and view everything. And this is where our GE MDS Orbit product comes into play. And this is the one we are going to talk mostly about today in terms of the distribution applications. And this platform allows us to put multiple applications on the same box with dual uplinks. They could be cellular or they could be cellular and private at the same time. A bit more information on the Orbit platform. This is a rugged, hardened M2M routing gateway that can do layer 3, layer 4, layer 2 switching, layer 3 routing. It's got a full-fledged security capabilities, including firewalling, IPsec VPN, authentication, secure firmware, secure boot, X509, and so forth. And we've designed this device specifically for rugged applications, and the majority of our deployments are within critical applications like utilities and oil and gas and so forth. On the communication aspects, we have two products. The MCR on the left side, this has 2 NIC cards and can handle 2 radios. They could be a cellular radio and a private radio. And the one on the right, this is just a simpler half-size model. It has only 1 radio. And based on our discussions with customers, the value of these products, especially on the MCR, is the dual capabilities of cellular and private communications, and we'll see some examples coming up shortly. In terms of ruggedness, we've had a lot of the MDS business has been selling and making products for about 30 years. GE bought them in 2007. We have a lot of customers with radios that have been in service for 15 plus years with no issues. So the product line is very well known for ruggedness. And just for fun of it, we took the Orbit, we ran over it with a truck, we shot it with a shotgun, threw it up 30 meters in the air and then on the pavement, and came back up and running, with the only exception that we just lost the label on it. So it's a pretty rugged box. And the reason actually I'm mentioning this here is if you want to offer a reliable grid and with highly available, the network is one consideration, but also the product at the end needs to be highly durable and highly rugged. Product like this has a 50 years mean time between failures, so it's pretty rugged. Now, one of the technologies on the Orbit one I talk about today is the NX915. This is a 900 megahertz unlicensed kind of broadband technology that can do 1.2 megabits per second. The reason we're positioning this one for these kind of applications is due to the fact that we've actually changed the way the 900 MAC works on it. We've improved the performance to go up to 1.2 megabits per second. But most importantly, the latency on it can be as low as 5 milliseconds, and we've tested as low as 2.5 milliseconds one way. So this is actually an overkill for a lot of applications, But once we start talking about distribution protection and DG protection, this becomes very important to have. There's a whole bunch of other stuff on it, including, RF encryption, authentication, so forth. So we made sure it's secure at the RF layer. And on top of that, we can do IPsec VPNs and firewalling at the platform layer. The technology can be deployed in a self-healing mesh, like you see here. And there's two modes for it. There's the best available path, which if a router loses a primary path may take up to 2 or 3 minutes to find the best available path. There's also the first available path, which is upon a loss of a link, it looks up in its table and picks up the first available one that you find. So the convergence time can be in the seconds, maybe 5-10 seconds, much faster, but you may not get the most optimal of links. So at least there's some flexibility here. How the Orbit MCR can be deployed. So this example here shows an example where we have two uplink carriers, carrier A as a primary and carrier B as a backup. Upon the failure of carrier A, whether on the physical layer or at layer 3, the router automatically moves forward to route B, which is on carrier B, to maintain the link. So this is, we're doing availability here using two cellular uplinks. Another model, which actually this becomes more actually important in a lot of cases, is to use private communications such as 900 megahertz unlicensed, or even narrowband, like we're releasing in a month or so. So these would be the primary path for communications. This is a private network owned by the utilities, and the backup path would be a cellular. And one of the main reasons to do this is to save costs on cellular, because especially if you're running multiple applications downstream, including voice over IP, video streaming, in addition to SCADA and protection, then cellular becomes very expensive because you're talking about gigabytes per month per location. So for this reason, you use a primary network as your 900 megahertz, and if that fails, you fail over on a cellular carrier. Now, Z's going to talk more about this, but just to kind of give you guys a tease, in my view, one of their major differentiators is the ability to fail over between multiple carriers should the primary one fail. So that alone can give almost 4 nines or 99.995% uptime, just because you have multiple options of carriers to choose from. So in that scenario, you get the primary link 900, and the secondary link is not just one network, it's multiple networks at the service of the application. This is another example showing how a converged field area network is utilizing the 900 megahertz both as downstream to the remote site. So the device in the middle here, this is a distribution substation router, talking downstream to reclosers or AMI collectors or renewable protection applications. The same link can talk uplink to a 900 control center or maybe at the transmission station level, with a backup on the cellular as well. So you get at least two paths for the uplink for higher availability. And this example here shows a different way of deploying the application. So you got 900 on the downlink from the Orbit MCR. So this would be the access point here. And downstream from it is a network of up to 500 devices that can span up to 30 miles between devices. So it can actually extend pretty deep into rural areas where cellular access is weak or non-existent. And at the edge of this network, we talk to the nearest cellular uptake, which could be, your typical cellular carriers. So in this example here, we show how we can extend the network into rural areas reliably using a self-healing mesh and at a lower cost, because for the cell carriers to come and install a tower in a new area, they require a certain amount of customers. And usually it's a longer process, so this would be a very fast approach to solving this problem. A couple more examples. This example here shows 3 distribution substations, and we're doing multiple applications between them. So if you look at the one on the left side here, there's internal goose or 61850 protection happening at the substation layer. There's SCADA happening as well. There's voice over IP, video over IP. There's workforce enablement, so employees using their laptops to access email or maps or topologies for the or diagrams. So all these applications are happening, and then they need an uplink. And with quality of service, and traffic shaping, we can give each application its own bandwidth and priority. So this way, Goose goes out first, SCADA second, and this way we ensure, let's say, voice over IP does not overtake the network because video is usually intensive. So with these kind of technologies, we ensure that even a bandwidth of 1 megabits per second is sufficient for most of these applications. And as a backup, we also use the cellular as a backup. And in scenarios where there's Goose going between the substation, and Goose is a layer 2 multicast protocol, the backup through the carrier can be done using a GRE tunneling protocol. So we tunnel between these sites at layer 2, and then just to kind of extend the layer 2 domain over between these substations. The final example I have here is one for the DG protection. So you got a renewable site on the left side here with a recloser controller and using the Orbit platform with a secure 900 megahertz uplink and a cellular backup. So now, since we're using 61850, this is definitely a layer 2 network. So we have to do GRE or layer 2 tunnels between these sites. And this actually, we can still do it through the cellular network using GRE capabilities. So the primary link would be 900 and the backup would be cellular. And the controller in this case would be located at substation layer. So this is my piece. In summary, I think one of the major aspects of us helping utilities drive higher availability in the network is to offer a solution that has that can utilize both cellular carriers as well as private communication simultaneously just to achieve higher availability. With that said, I'll turn over the slide deck to Z to talk about the Aeris piece.
Edgar, thank you so much for those remarks. It's really good stuff on there. And a reminder to everyone that you will get a copy of the slides after the session via email. And also a reminder that we're going to do a Q&A after Z is done talking. So if you have any questions, put them into the Q&A box. So with that, I'll turn it over to Z Hossein.
Thank you, Dana. Edgar, you did such a wonderful job of describing all of the capabilities that are necessary for these strategies that I'm going to focus my slides more on the cellular aspects and covering what Aeris does first, and then describing in some detail some of the special functionality we have implemented to allow applications like these to work better than on traditional cellular networks. So with that said, first few slides will be on Aeris, who we are, to introduce us to the people in the audience who might not know about us. We are a company that has been focused on machine-to-machine and IoT services for a number of years. We're headquartered in Silicon Valley IoT, and that's all we do. We do machine-to-machine IoT. The solutions we provide is a platform, complete platform from connectivity to application enablement. And you'll see a little bit more about that in the next couple of slides. This allows us to offer a capability, a one-stop shop for the customers who need these kinds of services to come to us, and they could take advantage of our connectivity services, they could take advantage of our application enablement, or the whole gamut from one end to the other. Recently, we also created a new platform we call NEO for people who are doing development as well as smaller businesses who are deploying M2M applications to be able to get their applications deployed rapidly. Quite literally, if you have a pre-configured box that allows you to use a SIM that can be delivered overnight, and you can be operational in 24 hours and go from getting your box loaded onto the network, getting data, managing it, operational, tested, etc. Our customers are typically enterprises. We do not deal directly with consumers in any way, shape, or form. Enterprises who are deploying machine-to-machine and IoT applications, who need connectivity, who need analytics, who be able to make business decisions for their businesses, etc. In terms of numbers, our infrastructure is highly reliable. We have multiple sites in the United States, one overseas, and adding to that in the future, with a great presence for machine-to-machines, because in a handset environment where people might tolerate service disruptions, machines don't. So we are very careful about how we make changes to our network and our infrastructure, etc. We're currently operational in over 190 countries. In terms of units deployed, machine-to-machine units, we're third largest in the U.S., ninth approximately globally. That number obviously changes occasionally. We're currently supporting well over 250 million messages per day. Let's forward the slide, and there we go. Is it forwarding? Okay, here we go. The markets and services we have. There are 6 basic markets. I apologize slightly for the one word got a little moved there. 6 basic markets that we serve: healthcare, telematics, consumer auto, monitoring and control, point of sale, and utilities. Obviously, the smart grid applications fall into the utilities camp. These markets are served by the platform that we have, which ranges from data and voice connectivity, device and IP session control, all the way up through the provisioning, activation, billing functions, and then connectivity enablement for the customers to be able to manage their devices, and application enablement so you can then get access to the data, the content that the devices are sending out in the field. All of this is cellular-based. We currently operate on over 500 carriers around the world, offering services in both 2G, 3G, CDMA, as well as GSM, and our 4G deployment, our 4G LTE deployment that is going to happen it's quite imminent. It's going to happen very shortly. We've already announced it. In the utilities and energy space, the typical customers who are deploying applications fall into 3 basic categories. You have the electricity and gas functions, typically the residential metering, the AMR and AMI functionality, the commercial and industrial metering, as well as smart grid applications. In the water utility markets, we are providing these capabilities, connectivity services to the companies who are deploying smart water meters for usage billing as well as leak detection. And these are typically being acquired by municipalities who need to be able to monitor and deliver and measure water. In the energy space, we have a number of customers who are working on solar panel monitoring, as well as the electric vehicle charging stations, the card swipes that you might have seen deployed at a number of airports and businesses around the country at this point. And of course, alternative energy monitoring. There are a number of companies who are deploying machine applications for monitoring wind generators, etc. Now, what is our technology? What do we do? What you see here on this slide from the bottom up is the connectivity services that we provide. We call that Air Connect. It's all cellular at the present time. It goes into our core network. Now, I want to emphasize something very important about Aeris. The core network that we have is indeed the kind of equipment that you'd find at a cellular operator, a complete carrier functionality, if you will. While we don't have RF spectrum, we operate and deploy our own core network with all of the equipment necessary to supply cellular connectivity services. This is enabled by the connectivity enablement platform that we call Airport, where all the devices are managed, for information and status of the devices provided to our customers. And then we have the application enablement platform, where the content analysis, if a customer chooses to use that platform, that's where the content is analyzed and the analytic functions and reporting capabilities are provided. And of course, the applications in green are the customer applications. On the right-hand side, you see our machine-to-machine BSS back office and operational systems that provide all of the billing functionality. This is something that we consider very core to our network in the sense that billing functions are essential for low-cost application deployment, and that's one of the advantages that we believe we have over traditional operations, is that our cost of billing, our cost of bill generation, and the fact that we do our own core, including development and design of some of the equipment in the core, allows us to offer services at a price point that would be tough for other people to match. And of course, as mentioned, we provide services in all of the technologies, CDMA, GSM, as well as LTE. The optimizations that we have done for the M2M infrastructure that we deployed, the network that we deployed, includes, I'll pick 3 items over here as an example, but it includes the optimized M2M radios. In our radios, there are multiple, in some of the radios that we have deployed, there are multiple what we call enhanced service selection mechanisms. This is what Edward was referring to, about the ability to switch between carriers in a market if there is an issue with a localized problem with a given tower, given range, a problem to a given tower, or a particular carrier who might have some outage conditions that need to be compensated for. And obviously, we do OTA management of the radio parameters to optimize the behavior of that device on the network. And as I mentioned earlier, we have our own custom network infrastructure. Now, some of these acronyms are probably going to be confusing to people who are not familiar with cellular, but let me just put it in the following way. The functionality ranging from number management and presence on the network, which is what an HSS and HLRs provide in 4G and 3G and 2G cellular, all the way up to policy controls, which is what a PCRF does in a cellular environment, allows us to completely control the operation of that device on our network. So we can granularly set the unique service and custom application requirements that a customer might desire. You can create custom policies for service control and manage the presence of the device on the network and usage of the network. If a device exceeds the threshold, automated functions can come into play to either disable it or notify the customer saying, hey, your device might be exceeding the amount of bytes you have signed up for, you may have a cost issue that you need to worry about, etc. And finally, that third bullet point is that we have a very flexible billing environment and the real-time reporting capability. The billing environment in particular is exceedingly important because you need to customize the plan to match the specific business model of the applications that are being deployed by the customer. You might have a customer who's deploying a few megabytes deploying applications that use a few megabytes per month, or deploying applications that might use a few hundred megabytes per month. So you need to be able to do cross-rate plans and pooling. You might want to have automated activation where the customer doesn't have to call anybody or even log into our portal. They have pre-set it up that after a certain number of bytes have been sent or a certain number of SMSs have been delivered, the device automatically transitions from what we call a provision state to an activation state. And I'll have a few more comments about that in a moment. The key capabilities that we have provided in our solutions include the ability to serve the markets for the AMR, AMI, and the DA applications, specifically the connectivity, the data being transmitted, control of the equipment that's out there, including secure access. Our data does not end up on the internet. It is going to be delivered to the customers who need to have it through private connections or through VPNs, etc. Very secure as much as we can do so from a practical basis. One device cannot talk to another. A customer who's competing with another customer on a network can't see the presence or behavior of the other customer's devices, etc. Our Air Cloud solution is transport independent. A very important point is that even though we offer cellular connectivity services, the fact that Air Cloud itself is completely independent of that transport could allow other IP sources or other data sources to be fed in, including wireline IP if that was a source of data for that particular application. So basically what that does is provides cloud data storage as well as the analytics functions for the alerts and reports and everything else that you might need to, a customer might need for taking the business actions that are necessary for that particular application and their business. And of course, we have complete portal access to the device management functions where the customers can manage the device provisioning, the activation, change the status of a device, or indeed suspend a device if they have a seasonal application, for example. That's where also you can set thresholds for alerts, you can debug device behavior in the field, and monitor basic functionality of a device. Is it registered? Is it operational? Is it transmitting data? Is it in a data session? Information that is critical to any M2M application, but particularly more so with an application where data gathering in a DA application is important. So what do we do? And this slide summarizes the differences. This slide summarizes the differences between what a traditional cellular operator does for the handset market, which is data transport services, and we wrap extra capability in seven different areas, ranging from service and performance enhancements all the way through customized flexible billing, including complete device traffic monitoring. I'm not going to talk about all seven of these. I picked a couple, two or three of them, to give you a little bit more detail and depth into that box and what that box means, why are we different, and why do we provide these M2M cellular services in a way that allows customers like GE and others to select us as opposed to a traditional cellular solution. So the first one is the coverage and reliability, the multiple carrier selection capability. This falls under the service and performance enhancements that we have done. In our CDMA solution, we can allow the device to pick from multiple carriers using algorithms based on perhaps on signal strength rather than carrier priority. These enhanced service selection methods allow a device to operate I'll use the qualified word better, and what does that mean? It means that if you have a problem with a device operating on one network or on one carrier in a particular region, it can find other services, other carriers that provide that capability for them. You get in general, more reliable operation. Typically, remote and fixed devices benefit the most from this. Remote devices because they might be in marginal conditions, or fixed devices even in local condition issues where it would be impossible to take that device and move it. The typical compensation that a handset cellular user does by walking away to a different location to be able to make a phone call doesn't work for a fixed device. move the slide forward here, and there we go. The second one is I picked two of those 7 categories is the customized flexible billing. We actually pioneered back 20 years ago the concept that provisioning is distinct from activation, meaning that you can have a device that is live, that is active and ready to go without incurring a monthly charge. I'm pleased that other people are now offering the same kind of capabilities because this is kind of fundamental to high volume production. You cannot wait for every device to interact with a human being to become active, to become capable of being operated on the air. We had requirements that were set on us by some of the high volume manufacturers that they wanted to be able to do factory provisioning and live on-air testing without triggering the billing functions because the device might go into distribution. So we did that. We also provide very detailed and also summarized billing reports on every device in electronic format, including grouping, because we have customers who don't necessarily sell to individual devices to end users. They're selling large blocks of devices to their enterprise customers, and therefore, if they want summaries, they can create groups within the system to allow them to group the bills for a single customer that they have. We also do very effective rate plan matching to the specific customer needs, their business models. What you might see in a traditional cellular operation where rate plans are fairly small, what I mean by that is fairly small number of rate plans. We literally have thousands of rate plans because every customer who needs an optimized solution for their application will typically ask for a different rate plan. Plus the fact that we can do pooling of data usage across devices in a given application or even indeed across rate plans. Support. Another important aspect of machine devices is that you need to have the ability for the team who responds to the issues understand that these are not handset cellular devices. The needs are different. So we have a operations team that monitors our network literally 365 days a year, 24/7. We have developed our own automated systems for monitoring thresholds and conditions under which M2M devices operate. Let me give you a simple little example of why that is different. A typical application has a pattern. In general, once a device starts transmitting on a particular pattern, not always, but in general, you will see the repetitive pattern very easily. You'll see that customer's devices come on at a certain time, transmit at a certain time, and may have a specific usage pattern that our engineers, our support personnel will recognize, and over time they'll be able to put filters in place that say if that pattern's not happening, then they can recognize that they might be able to proactively notify the customer of an issue. Our personnel also understand the applications. They know that these devices are operating differently than handsets. So we've built up some special data and filtering tools to allow us to go in there and look for these kinds of anomalies and patterns that a device might have. Indeed, isolate whether it's a device problem or a network problem very rapidly, because that's sort of the traditional place where you need to understand is something not working properly. In addition, when we do have a remote problem, we interact directly with the remote carrier staff associated with that particular location. So this gives us the ability to resolve network issues much more rapidly. We're not in line with consumer support requests that might be coming in. We're interacting directly with the operators and technicians of the remote carriers. Indeed, we've built up a relationship with all of them, so they understand that we're going to do a lot of debugging well before they ever hear from us, and therefore when we're calling them, we genuinely have some issue that they need to address, and it may be impacting their devices as well. Quite often they will discover that we can provide more information about their network because we know we can see a repetitive pattern where a handset customer may not be able to see that pattern. So, in summary, cellular in general is an extremely capable transport, and what we have done to build capabilities on top of that to optimize for remote multi-carrier transmission and control, the kind of cloud analytics that our customers are asking for their business intelligence functions, makes our solution just that much better than traditional cellular. What we do is we provide a reliable managed service for M2M devices. This reliability is essential for machine devices because human intelligence can compensate for the occasional glitch a machine that's doing a specific application cannot. We have to manage the devices better within our cellular network, and our customers benefit from that. And of course, in general, because of the fact that these devices are usually deployed by enterprises in the tens of thousands or hundreds of thousands, you need to control your costs very carefully, and you need to optimize the plans, the rate plans that you're using, the pooling that's being done, as well as receive the alerts if you have a device that is causing a problem on the network or is running away and might exceed the cost controls that you've decided you want to have. Indeed, in some of our solutions, some of our customers are willing to have automated device shutdowns, basically turn the device off from transmission if it exceeds a certain threshold from usage or allows them to manage costs better. So that's my summary. I'm going to hand the baton back to you, Dana, and there's my information. If you need to have additional information about Aeris, what we're up to, please feel free to contact us.
Perfect. Thank you, Dee, and thank you, Edgard, again. Before we go into Q&A, I'm just going to throw up our second and last poll question here. And there it is. So we want to know a little bit more about you and what's your organization's current status in terms of deploying the smart grid. Now, let's go, and you can see that over on the right side of your screen, but let's go to Q&A. So we've got a couple of questions here on security. Let me start here. And this person asks, can you talk more about security? I want to know where systems are most vulnerable and how we can ensure, or what steps we can take to ensure that our data cannot be hacked. I think probably that's for both of you. Edgar, you want to start?
Thank you. You know, there's a lot of steps we can take to mitigate security, and at least on the Orbit platform, from a high-level perspective, there's a whole bunch of features. We can group them in three categories. From there's security features to secure the device itself. These would be secure boot, so the firmware cannot be changed and put on the device. It will not accept it. It's because there's certificates that have to be matched with or keys with the hardware as well. So there's hardware to software interaction as well there. Securing device, there's authentication for user, which is standard pretty much everywhere right now. Securing the network, which can be done via firewalling. We support layer 3 and layer 4 stateful firewalling, in addition to MAC filtering if needed. There's also the IPsec VPN encryption, and there's also for private communications such as the 900 megahertz or the narrowband, there's the RF layer encryption in addition to IPsec encryption. So encryption all over the place here. So this is at least these are some of the mitigation steps we take on securing communication coming through the orbit. And Z, would you want to talk a little bit about how you guys do it with the Aeris network?
Sure. On the cellular side, I mean, ultimately the thing that, I always caveat my statements with the following comment. RF in general can be overheard. So if a particular hacker wants to spend the money necessary to be able to break into the RF wireless side, there is essentially no real way to block that. However, once it reaches the mobile switching center and then connects into our network, we deliver all of that data information is delivered through very, very secure. They're not accessible from the internet. They're private lines, typically from all of these sites directly to our facilities. And then we deliver our data through private lines to the people who want complete security, or even VPNs for the customers who are willing to allow the data to traverse through a secure channel over the internet. Clearly, firewalls are essential. We have the number of places where we have firewalls. Our corporate network can't even access our production network. For example, our corporate internal employee network doesn't access the production network for data, etc. So we worry about security. We're careful. Is it the best in the world? There's nothing is perfect, but we do the best we can to make sure that the devices are about as secure as you can get. One other comment I might make is that our devices don't show up on the public internet, meaning a cellular device operating on our network does not have an IP address that can be accessible from the public internet. So if there's going to be any kind of security or issue, it'll really relate to the systems behind it, not to the specific devices that are operating in the network.
Okay, good. And there was a follow-up question. I want to make sure that we have this covered. He asks about if we could speak a little more to secured access to devices. Do you feel like we've...
I think we've covered that.
Okay.
Yeah, would you add any more comments to that?
For the Orbit platform, it supports SSH, remote SSH, and HTTPS as well. So these provide encrypted access to the modem or to the router. in addition to radius authentication. So the user, once they hit the device, they would have to be authenticated either locally or at a central location. So these are the two main aspects for enabling secure access to the device.
All right, cool. Thank you both. Z, this is one for you. Is Aeris a CDP, a connected device platform like a Jasper, an M2MZone, or a Core?
We have similarities, but let me emphasize a few differences as well. We offer a complete platform from connectivity services all the way up through the application enablement. There are pieces of our solution that overlap what companies like Jasper and Core have to offer. Then there are other pieces that don't. For example, if a customer uses our connectivity services, then that is a platform that we consider basically on par with the traditional cellular environment, with the caveat being that we don't do the radio cellular portion of it. We do everything beyond that, including management of the devices, numbering issues, management of the numbers in our platform, etc. If a customer chooses to use our our application enablement platforms like AirCloud, then they have access to be able to manage their content. Under normal circumstances, we don't manage the content for the customers unless they want it to be done through AirCloud. And of course, our platform, the Airport platform, does all of the device management, the presence of the network, the provisioning, the activation, the device status. Is it registered? Is it in a data session? Can you reach out and touch it, etc.? So there are overlaps, but on the other hand, because we're more of I would call it traditional roaming carrier rather than an MVNO, such as Jasper or Core, we're a little bit different. We have optimizations built in because we have access to the network, which sometimes they don't.
Cool. Thank you very much for that, Z. And a reminder to all of you, we have about 5-6 minutes left. If you have a question, you can put it in the Q&A box. Here's one. Can you describe why real-time is important for M2M? Edgar.
This is actually important for many applications, especially in the context of our discussion here, which are utilities. And actually, the funny thing is, real-time means something different for each application or for each customers. For SCADA, real-time is about 1 or 2 seconds. For protection and the distribution, it's hundreds, like 50 to 100 milliseconds. Transmission, it's 3 milliseconds or less. So it's very, very varied all over the place. Now, for M2M, usually, the applications today are merging mostly into live monitoring, They want to know at any time where things are in terms of assets, location and so forth. So for this reason, having a responsive, instantaneous network is very critical.
Okay, cool. Edgar, you put a lot of great content into your slides, and we have some questions related specifically to that. So does the GE solution support a device that has integrated crypto controllers for a TPM type approach? Cryptography done today on the Orbit platform, at least, is done in software. We don't have, per se, if I understand the question correctly, hardware controllers or accelerators as well. However, there's very powerful, the processor on the box is pretty powerful and can handle a big load of the cryptography, so it's not a problem at all for that purpose. Okay. From your experience in increasing the reliability of the access to the devices, are there other solutions than utilizing the multiple carrier approach? So, for example, having a mix of wireline access and wireless access towards the device.
Certainly. I think that is certainly possible. If a customer and an application have a need for a different kind of IP transport, definitely we can support that. The key is, where is the data going? And if the wireline data is going through an ISP network directly to the customer's servers and not interacting with the internet, great. You now have the ability to provide secure access over there. Can you have a variety of networks providing that IP transport? Of course. It all depends on the application. We've got, and of course, as Edgar had mentioned, you might have a need for multiple redundancy in situations where the data integrity and reliability is important to you. We have seen customers do hybrid solutions. where they have multiple networks, cellular networks as well as wireline networks, and in some cases, not in this field, but also satellite connectivity, such that if the device which is mounted on a truck that goes outside of cellular coverage needs to send data in an emergency alert scenario or whatever, they can communicate with the satellite. Certainly possible.
All right, let's talk a little bit about failure rates in the technologies that you all have been describing. And what about the lifespan of these devices? Edgar?
The GEMDS devices typically are, built for industrial and rugged uses. So from the ground up, we make them rugged, and we have so many standards we follow, including IEEE 61850-3, 1613, and so forth. So there's no fans, there's no moving parts internally for reliability. Typical lifespans for these devices, the mean time between failures is about 50 years.
Okay, well, that seems pretty good then, doesn't it? One for you there, Z. Let's see. Does Aeris have a private 900 megahertz network?
No, we don't. We currently operate and deploy our services on a cellular environment because the radio towers that are out there are owned and operated by the traditional cellular operators that have deployed handset services. So we chose to do it that way because we wanted to get coverage up and running as quickly as we could, and given that they had already deployed the towers necessary to provide that coverage, we chose to go and use the traditional cellular networks that were out there. Now, having said that, there is a tremendous growth occurring in the M2M industry. Everyone has heard the large numbers that are being thrown about, that in the next 6 to 8 years, you'll see billions of devices on the network. What's interesting is that my estimate is only about 4 or 5% of those devices will be cellular. So it's natural for companies like ourselves to look at ways to add connectivity capabilities, new transports for devices that don't fall into the cellular transport mechanisms, can't fit into that transport mechanism very easily from cost or power perspectives. So does it make sense for us to look at other networks in the future? Certainly. Do we have any plans on that, deploying something like that quickly? No. I think we're building up steam on the cellular front so much right now that looking at other networks would be a futures issue for us, not an immediate thing.
Okay. Well, we have run up against the hour, but we still have more questions here. So I want to create a couple of opportunities for you all to get your questions answered, or if you have more of them after the session. So we have set up a Twitter hashtag. So that hashtag is GEARIS for utility. So I'm just going to say the letters GEAERIS, the number 4, YOUTILITY. That'll be an opportunity for all of us to get into a conversation or continuing this conversation. Also, you can send questions directly to Aeris at info@aeris.net, and we will be sure to share those with Edgar and Z as well. So that is it for us today. Lisa, back to you.
Thanks so much, Dana. That's terrific. And on behalf of the M2MZone, thank you to Z and Edgar, and thank you all for joining us today. A recording of today's webinar and a PDF download of the slides will be available by the end of the day tomorrow on our website, M2MZone.com. Just watch for your post-event email, which will include information on the recording and the slides. Please join us for the M2MZone's next webinar on April 15th, New Directions for Wearables. You can register for this event at M2MZone.com. Thank you.